Hello everyone, in this tutorial you're going to learn about a symmetrical boundary condition in Abacus. In a lot of cases our geometry is going to be symmetrical, so it's not really necessary to model a full geometry to do an analysis, and this will reduce the computational time significantly, especially in a complex geometry. For instance, in this case, this is a very simple 2D model that, as you can see, if I model a 1/4 of this model, I can actually get the same result as modeling the full geometry, because basically I have a symmetrical line here, and also I have a symmetrical line at the top here. So if I basically just model this 1/4 and apply a symmetrical boundary condition to this line and also to this line, then you will see that the result that I'm going to get for a stress for both scenarios are going to be the same. Okay, so now let's do this one in Abacus. So we'll start from a part to create a sketch of our model. So click on create part. It's going to be 2D, deformable, and it's going to be shell, and approximate size, make this one 200, and click on continue. Again, I'm going to create those construction line which give me this 0, 0 coordinate, and I'm going to fix the both, and then I'll start with the circular circle, and the radius of this equals to 5, and then I'm gonna draw a rectangle from here to here, and always start with a smaller dimension. So from here to here I know that's going to be 25, and from here to here it's going to be 100. Sorry, that's going to be 50, not 100. And from here to here it's going to be 50, and from here to here it's going to be 100. So I'm done with this one. However, I only want 1/4 of this. But before getting rid of the extra lines, I'm going to save this sketch, because I'm going to use this sketch later to create a full model. So let's just save this one, and I'm going to call this one full model. So I have this one saved, and what I can do, I can actually edit this one and basically select a line and draw a line from here to here and another line from here to here, and then we can use that auto trim, and get rid of these extra line that we created. And there is no other line. We can also give a dimension from here to here. It should be 25, which is correct, and from here to here is 50, as you can see. So all the dimensions are correct, and also I have to get rid of the line here as well. So the circle, I'm going to get rid of these one as well. So cancel this one and click on done, click on OK. And obviously, as you can see, because I created the full model, I have to regenerate this one to have it as a 1/4. So we are done basically with the part section. Next step is to create a material property. So I'm gonna call this one still, and mechanical elasticity elastic. Young modulus is going to be still, so E 2.1 e power 5, and pulse ratio 0.3. Again, the unit system is megapascal. Sorry, the unit system is millimeter, so the unit is going to be megapascal here. Click on OK, and then we create a section for this one, which is going to be solid homogeneous. Click on continue, and then we have to give a thickness to this one. The thickness is 3 mm. Again, because we are doing a simulation 2D, we have to activate this one here to give a thickness. You don't need to activate this one when you're doing a 3D or shelled 3D. Okay, this is only for 2D. Click on OK and assign this one to this body, and click on OK. So we assign our property, next step, to import this one in assembly. So it's going to be dependent mesh on a part. Click on OK, and then in the step section I'm going to create a step which is going to be static. Click on OK, and so make this one 0.1, this is 15, and we can make this 1000. Click on OK, and next step is the interaction. So again, in interaction we don't need to do anything because the geometry is simple, we don't have any contact, and also we are going to apply a pressure, so we don't really need to use the coupling to create a node. So I'm going to go to load, which is basically a section that you're going to learn something new to apply a symmetrical boundary condition. Okay, so in the load section, click on create boundary condition, and we're going to go to symmetry and click on this one. And first we're gonna do this one, so I'm gonna click on this, and I'm gonna select the first one. So that means that displacement in X is 0, and we don't have any rotation in his Y and Z axis. So this is symmetry about X plane. Click on OK. And I'm going to do the same thing for the bottom one, so click on continue, select this one, click on OK, and this time I'm going to select the Y, so there is no displacement in Y axis here, and also rotation about X and Z axis equals to 0. Click on OK. So now I'm going to apply a pressure. So go here, we apply pressure, continue, select this one, click on OK, and let's say this is 147 Newton per millimeter, and then click on OK. So that's basically in a compression. I'm gonna just change the value. I'm gonna make this one minus, so that will apply it in a tension direction. Okay, so we are done with this one as well. Let's go to mesh part, and we'll try to see that if we can apply structure mesh. We can, and we give it a mesh size to this one. Let's make it 2. Apply. Okay, assign this one, say yes. So this is our mesh. I mean, obviously it's not really a fine mesh. As you can see, we don't have a perfect circle, but I mean this is okay for this example, but obviously if you want to do a real simulation, you have to apply much finer mesh around the circle, or what you can do, you can also isolate this a circle by doing a partition here and apply a much finer mesh around this corner. So let's minimize this and create a job. So I will call this one Symmetrical 1. Click on continue. OK, submit a job. So now let's see the result. This should be a quick simulation. Yeah, so the job is already done. So I'm going to close this one, show the result, and the stress is 311 megapascal. So now, as you can see, we can only see the stress for a 1/4 of the full geometry. But however, we can also see the we can actually render, or let's say plot the full geometry by going to ODB display option, and from here, mirror and pattern. If you activate XZ, so XZ is going to be this axis. So if I apply this one, you'll see that we have the other side of this geometry. And also if I activate the YZ, which is the green one and the blue one, so we're going to have the mirror of these on the other side. So if I apply this one, you'll see that this is going to be our basically model. So that's a 311 megapascal, and this is basically a render of the full geometry. So I'm going to just deactivate these renders, and we can now start making a full model. So let's create another copy of this. I'll call this one maybe full model, and so in a part section, what I'm gonna do, I'm gonna go here and edit this one. And what we can do, we can get rid of this one by pressing on here and just get rid of everything. Click on OK. So we don't really have a line. As you can see the geometry there, but we don't have a line. So if I click on OK, so basically I'm going to have no part. But then from here I can say add a sketch, and I have the add full model here. So if I click on OK, you'll see that you can see my model here. Obviously it's moved slightly, so it's not anymore in center, but it doesn't really matter. As I said, this is just a guide, and it doesn't really matter that this be in the exactly in that middle. So if you click on OK, say yes, and if you regenerate your model, you can see the part here. So this will save a lot of time because you don't have to create a property anymore. What you need to do, you need to actually apply a property to your new basically model. Before applying a model, before applying a property, you have to go to a section assignment and make sure that you get rid of the previous section, because obviously I can apply a section to this one and say this is section 1, but if you go here, you see that you have two sections, which is one section you actually apply, but one section is from the previous design, and if you try to run it, you'll have an error because you have like two sections here. So get rid of this one, click on yes. So now we are done with this one. Assembly should be fine, step it's fine, interaction is fine. Load, so here in load we don't anymore have a symmetrical, so what I can do in the boundary condition, I can get rid of these two boundary conditions, and I can just use a pinned one, or we can use this one as well, because we consider the rotation on the other one. So I'll click on this, and also a load. So if I double click on load, I'm going to have a error that the line is missing. So I say yes, and I'll select a new line here, edit the region, and I can select this one, click on OK, and that's it. So I basically reapply the load that I created. And in mesh section, if I go to part, you'll see that I won't be able to apply a structure mesh anymore, and this is because the geometry is too complex for Abacus to do that. But we can solve this problem by creating a partition. So I can do that by creating this partition and do it from here to here, and also from the top to bottom. Make sure that they're exactly in the middle. Click on done, and if I assign this one to here, you'll see that I can apply a structure mesh, and then I can give the same dimension to this. So I can say 2 and assign a mesh. So this is going to be our basically full model mesh. So now I'm gonna create a new job. Gonna call this one full model 1, click on OK, and I'm gonna submit this one. So now we can monitor a job to see that if we're gonna get any error. The job is done, and so we can see the result. So as you can see, the stress very close to the previous. If you remember, in the previous analysis the stress was 311, and here is 319. And so I mean, obviously if we apply a finer mesh, we will have a much better result, more accurate result. But this was just to prove a concept that you can actually use 1/4 of the this geometry and you get the same result. So this is the basically last tutorial of the basic section. In future I might add more tutorial to the basic section if I found out that there is something that I can add so you can learn more. And after this tutorial you would be able to go to improvers section and do a tutorial, do those tutorials. But I definitely recommend you to for this course, in order to learn it, you have to have done the fundamentals, all the basic example, and then go to the improvers. And once you finish the improvers, then you can look into the other courses in Udemy website. There are loads of intermediate courses. I also have 3 other intermediate courses that you can look into my profile, and if you find them interesting, you can try them. Thank you so much for watching, and I hope to see you in the next section.